let's discuss few properties of matrices. See, when I say properties of matrices, we are talking about the algebraic properties of matrices. Okay, so what algebraic expressions and what algebraic operations can be done on matrices. We'll start with the most basic of all, which is addition. Okay, now we'll start with matrix addition. Alright. Now in matrix addition, it's a very simple one. Okay, very simple. Now the most important and the very first thing what you have to understand is that the order of the two matrices should be constant. Fair enough? Without the same order, you won't be able to add. And isn't it quite obvious? Because the corresponding elements only we have to add, right? So without that, you won't be able to add the matrices. So we can say that let A, matrix A, given by A, ij, is of the order m cross n. Some order m cross n. And say matrix B is equal to B, ij. This is also of the order m cross n. Then you can just add the corresponding elements of A and B and you are going to get the answer. Alright. Now I'll give you a simple example. We'll start with 2 cross 2 matrix. Or let us take a different types of matrix. Okay, let's not take square matrix. Let's do some other thing. Let's say we have matrix A is equal to 2, 1, 5, 7, 1, 0. Now this is a 3 cross 2 matrix, correct? Let's take matrix B. Now, very first thing, the prerequisite is that the order should be 3 cross 2. You cannot take 2 cross 2 and say, okay, I'm going to add it. Not possible. So matrix B, minus 1, 7, 8, minus 2, 5, minus 1. This is also 3 cross 2, correct? Now you can do A plus B. The order of A plus B is also going to be 3 cross 2. Okay, now what do you do here? You take 2, you take minus 1. So you add the corresponding elements. Okay, so when you add the corresponding elements, 2 plus of minus 1, correct? 2 plus of minus 1, 1 plus 7, 5 plus 8, 7 plus of minus 2, then 1 plus 5, 0 plus of minus 1. This is going to be the matrix. Now take this, simplify it. So A plus B is equal to 2 minus 1 is 1, 1 plus 7 is 8, then 13, 5, 6 minus 1. This is also of the order 3 cross 2. So what did we do? We added the corresponding elements of each matrix, correct? First row, first column, first row, first column. Likewise, if you keep on adding, you are going to get the sum of the two matrices. Alright? Very simple. Now, let's do few properties of addition of two matrices. Like, is it commutative or is it associative? These kind of laws and properties will do. Okay? So, let's do it now. The first property or the first law you can say is the commutative law. Okay? So, the first one is commutative law. You guys know what is a commutative law. I don't have to explain what it is. Correct? Now, matrix addition it holds good for addition of two matrices. In the sense it is true for commutative. Commutative law is true for matrix addition. In the sense, if you can tell that A plus B, this will be equal to B plus A. Now what I want you guys to do is just go to the go for the previous one. In the sense, just rewind back a couple of seconds and you can see that A plus B and B plus A are one and the same. Okay. So here what are we talking about is the commutative law. The next law is associative law. Okay, the next one is associative law. Here you are going to have three matrices, correct? A, B and C. So what we say is A plus B plus C is equal to A plus B plus C. This is basically associative law. Okay, so this is also true for matrix addition. The next one for matrix addition, what you have is the identity, existence of identity. See, identity, for addition, what is the identity? 0, correct? That means here we need to have a 0 matrix or what we call as the null matrix. That means you have A plus 0 matrix is equal to 0 plus A is equal to A itself. When you add null matrix, so there is a matrix which is called as the null matrix. When you add it to the given matrix, you are going to get the same result. Okay, so this is the existence of identity. The next one is inverse. Okay, additive inverse, what we call, correct? So the next one is additive inverse. See, when we talk about additive inverse, that means matrix A plus some other matrix should give you null matrix, which is nothing but minus A. That means we have A plus of minus A is equal to minus A plus A is equal to null matrix or the identity matrix. So for any matrix A, there exists another identity and inverse. Both of them will exist, which can be proved in some of the examples and problems later on. Okay. Now, for any matrix A, there exists an inverse, what we call as negative of matrix A, which when you add to the given matrix, that's going to give you a null matrix. Okay, or identity matrix, which not identity matrix, the additive identity, which is 0. Fair enough? So this is what we call as the 4 properties of addition of matrices. Commutative law, A plus B is equal to B plus A. Associative law, A plus B plus C is equal to A plus B plus C. That's the second one. Next is the identity, additive identity, and the additive inverse. Okay, these are the 4 properties. Now, in the next video, we'll discuss more properties on subtraction, on multiplication, and other algebraic operations.